welcome back, friends. This is Cajun Coding. I'm St. Raz, and we are continuing on our Java journey. We are in the String2 series of exercises, and we finished up code count last video, and we're now going to be proceeding on, pardon me, to EndOther. An explanation of the exercise here: given two strings, return true if either of the strings appears at the very end of the other string, ignoring upper lowercase differences. In other words, the computation should not be case sensitive. Note str.toLowerCase returns the lowercase version of a string. And as you might expect, there's a toUpperCase method as well. Let me see. Okay, so it looks like if either of the strings appears at the very end of the other string, so apparently one string, or the possibility is that one string is a substring in its entirety of the other string. So let me see. So, and it looks like there are two possibilities, either A, or I'm sorry, actually three possibilities. A is a substring at the end of B, B is a substring at the end of A, or neither is the case. We don't have to say which of those is the true, the A being in B or B being in A, just we would return true. This is a Boolean, you see. Our return type is Boolean, and the data that we receive into the function are two strings. So if we have A, and if we look at the very end of A here, it would be starting at the index of B length. Actually, it would be starting at, let me see, so it would be A length minus B length, I believe. And we're going to make it to lowercase. Equals B. Now that's not a complete solution, but I think that will work. Okay, so here we've got B is ABC. The last characters in A are ABC, and that's exactly what we were looking for here. So that actually does work, and this is one of those, incremental solutions that we like to look for just to make sure we're on the right track. Now what we're going to do is we're going to put an OR here, and then we're going to essentially copy this entire code, and what we're going to do is just replace A with B and vice versa. Ooh, now what happened? Looks like we've got some out of bounds here. So A, B, A. Okay. Is B? Oh, no, B is not always shorter than A. What's interesting though is that this didn't happen before. Let's see what we've got. Oh, I'm sorry. We actually did get some string out of bounds with the previous code. I was just looking at, I had tunnel vision. Okay, so let's go ahead and put this back. Okay, now what we're going to do, we need to make sure that we're not going out of bounds anywhere. Okay, so what we're going to do is we're going to add a condition to make sure that we're not out of bounds. Forget my semicolon. Okay, so what we're going to do is we're going to check to make sure in this first one, hey, that's, oh, I went too far. I rewound too far. This should be B. Okay, there we go. And I'm just going to run this just to make sure we don't have any other errors. See, it looks like the only problem that we have is the string out of bounds. So now we're going to address that. Okay, so on this first one here, we're going to make sure that A length minus B length is not out of bounds. So and how do we do that? A length minus B length. It would have to be, I believe it would be greater than 0. And we're going to grab this, and just as before, substitute the characters and we're almost got it. Let me see. So this is coming up false. Why is that? Maybe greater than or equal to 0. Now we're getting really fun stuff. What happened? So we fixed that one. Why is that coming up true? Curiouser and curiouser. I'm going to go ahead and break this up a little bit so we can read it a little more easily. Remember, the Java compiler is blind to white space. It doesn't see any of the line breaks or anything. So we're just going to break this up so we can read it a bit easier. Okay, so we've got our check. This is our check to see if B represents the end of A, and this is our check to make sure that to see if A represents the end of B. This particular part is making sure we don't come up with anything so weird. So let's go step through this. So this, we've got 1, 2, 3, 4, 5. So a string of 5 letters. And we want to make sure A length minus B length. So it's 5 minus 3. That puts us at 2. 0, 1, 2. Okay. We also need to make sure A length minus B length is greater than or equal to 0. If A minus B is negative, that means B is longer than A. And that's a problem when we look at this. So we want that to fail. We want this check, this Boolean, to return false. So that all looks correct. This is essentially a repetition of this with A and B reversed, which is as it should be. So why are our tests failing? Why is that coming up false? You know what? To lowercase. I wonder if it's the case that's doing it. Let me see, that's false. ABC, that is false. Okay. So I think we located it here. This to lowercase, I think I've got that method in the wrong place. Substring to lowercase. Doesn't look like it's in the wrong place. Maybe we need to put that last. Yeah, let's check that out. Okay. Let's see. Oh, I should have put Java. Java, not JavaScript. Java. Here we go. Stack Overflow. Why isn't the method to lowercase working in my code? Let's see what they're doing here. Really? S to lowercase, that's it? Doesn't work because strings are immutable. You need to reassign. Oh, now I see. There we go. Alright. I'm gonna make a variable. This is getting way too long for just a one line thing. Alright, so let me see, string X is going to be empty, and string Y is going to be initialized as empty. And we're going to fix this. We're going to get into the immutability of strings in just a moment. I would say somebody raise their hand and don't let me forget to mention that, but I guess that doesn't work in this context. Alright, so let me see, so we have X actually I can just do a return here. Oh no, that won't be, I won't be able to do a return. I'll explain that in a moment too. Let me see. I'm going to put some notes in here for me. And I'll put some down here. all this white space. Might as well use it with for something, right? Okay, so I've got that if closed, and I've got that if closed. This we're actually not going to use. The logic for this has all been replaced by the logic in these other statements. So return false if neither of those are true. Let me see. Looks like we got these enclosed correctly. Is this really going to work first time? And it still doesn't work. I think I've got the lower. It's got to be the lowercase thing, right? Okay. That's false. Okay, what test are we failing? Okay, this returns false. This should be true because Z is that last character. This should be true. ABC, ABC right there. Right here it works. So it's only the case that's messing it up. So what are we doing here? Let me try flipping this to put it before the substring. That doesn't make any sense. I'm going to do it anyway. Because sometimes, I don't know what the people who create the compilers are thinking sometimes. Sometimes it doesn't seem to make sense. And we're going to do the same thing over here. I'm kind of doubtful this will work, but might as well try it, right? No, it doesn't work. Yeah, it's got to be that that two string, two lowercase is not working for some reason. Let me see if I can figure that out. Maybe I'm complicating this. You know what? Instead of initializing these, everything's going to be lowercase. So instead of, yeah, that would take a few changes, but I think it'll work. We're just going to change these instead of initializing them to nothing, an empty string. What we can do is we can do a to lowercase, and then we'll do b to lowercase. Okay, so now we've got X and Y, but everything, or the formerly A and B, but everything is lowercase, so we don't need any calls to the lowercase method. And well, actually, this is where we're reassigning these, so we get rid of that. We're just going to be working with X and Y now. So we don't need to reassign these. Oops, I think I deleted too much. Definitely did. Okay, okay, X. We don't need the lowercase here. this is x and y. Really think this is going to work, guys. Okay, so see if okay, so we made sure our lengths are not problematic. Okay, and now once we've established that's not the case, no, this is too convoluted. Get rid of this. Okay. All right, so our lengths are not problematic. So if x and I don't need to worry about uppercase or lowercase. If x substring x length minus a, no, not a, y length equals y. Okay. Not a semicolon. Return true. Okay, so this is what we're doing, guys. So we've got x and y to replace a and b, and we wrote everything in lowercase. Okay, so now we're working with x and y. If x length, the first one, x length minus y length, if that's a negative number, then the first one's smaller. That's not going to work. Okay, so if that's not the case, we skip over this code block. If that is the case, if the a is larger, if a, oh gosh, if a, the first one, is larger, that's okay. If the second one is larger, that's problematic. So if the second one is larger, we're going to skip over this code block because the if resolves to false. If the a is longer, then we can check to see if b is the end of a. So the way we're going to do that is we're going to take the length, we're going to take a substring, length of a minus length of b, and that's going to give us the index that we're going to read from for the substring, and then we're going to check to see if it equals the second string that was passed in. Easy peasy. Alright, so now what we're going to do is take this if block and we're going to copy it. And of course we're going to replace y with x and vice versa. Okay, let me make sure I've got all these. That's not right. This should be lit up. That one's lit up. Let me see. Got one too many or one too few? We got one too few, I think. Or I'm sorry, one too many. Get rid of this. Okay, there we go. This should be the second if block. This should be the first if block. Okay, so now we just need our return false because we could not find a return true. Guys, I'm like 97% this is going to work this time. No. Miss parentheses. That's nothing. We got that. Alright, here we go. Really? Oh, well, because I copied it, so of course I copied the error as well. Symbol to lowercase. It's all about the parentheses today, isn't it? And it works. 24 minutes. That was a disaster. That was the first exercise. You know what? I'm leaving it up. I'm going to put it up there because that's how programming works sometimes. And you got to chase things down a rabbit hole. And I did leave myself some notes, right? Okay. I deleted these notes over here. This is an if. Okay. Why couldn't we just use a return here? Okay. Remember, I was about to do just a return. Instead of this if conditional, we use a return, and if the if conditional turns out to true, we return a true. That's fine. But in the case in which the if conditional returns a false, then our entire function would be returning a false, and that's not correct, because what if the reverse were true? What if it worked the other way around? Then we should be returning a true. But we never got a chance to get to this code because we already returned a value, and that's why for these if blocks I could not use just a simple return, had to use an if with a conditional there. The other thing I wanted to explain to you guys, string immutability. This is kind of weird, but in the Java language, strings are considered to be immutable. Immutable means it cannot be changed. Once you create a string, the string A cannot be changed by the compiler once it's generated and populated. Now, we've dealt with changing strings all the time, haven't we? Well, yes and no. We're not really changing a string because strings cannot be changed. What we're doing when we reassign a value is we're creating another instance and naming it the same thing as we named the original string. Now, for practical purposes, this doesn't actually come up that often, except in this particular exercise it did happen to come up because we were trying to change a string to lowercase while we were doing a comparison, and the compiler kind of balked at that. So to get around that, the immutability of strings, we're not going to try to change A, we're not changing B, but we're going to assign to X the exact value of A, with the exception that we're going to change it all to lowercase. Likewise with Y and B, and that's one of the things, one of the weirdness that you're going to encounter about the Java language. This isn't entirely unique to Java. There are other languages that deal with immutability. And like I said, this is not something that you're going to run into all the time, but it is something you should definitely be aware of. It does have some implications in terms of memory usage, because if you need to change a string a lot and it can't be changed, then you're going to be creating multiple copies that are different in some way of that string. If for some reason those previous copies need to be used for something, then they won't be garbage collected, and that's another concept in Java is garbage collection. An object that no longer has any valid references, for example, if there's no longer a variable that points to memory that's allocated for a Java object, then the compiler looks at that and says, hey, there's nothing that can reach this resource, and so it gets garbage collected. Garbage collection means that it deallocates that memory, and that memory in the system can then be used for anything else, really. But once that memory is garbage, once that object is garbage collected, it can no longer be reached. Or rather, I should say the other way around. Once it can no longer be reached, it's garbage collected. But those resources, in terms of those spots in memory, are then gone. So, but anyway, without garbage collection, which in Java is automated, in some other languages you have to program this behavior in, otherwise you'll have what's called a memory leak, and your entire system memory can be consumed by variables or other objects that you don't need and can no longer use, and eventually it fills up the entire thing and it all crashes, which is a weird thing about a memory leak. Memory leak in a computer means it can't forget things, and a memory leak in a person means they can't remember something, right? Alright, well, what an adventure. Wasn't that great? We spent almost 30 minutes on one exercise, but I hope you guys learned something from it, and I've certainly been reminded of some things from it. So I'm going to go ahead and publish this dumpster fire. Hope you find it entertaining, but you know, that's the way things go sometimes. And I will have another video for you guys up soon. Thanks for joining. See you next time.